Good morning, Cardinals. This is Mr. Ernst. So, we are going to be talking about in this lesson how we are going to go about stretching and flipping a graph. Last time we looked at this, we were kind of taking a look at how we would take a quadratic equation very similar to this, and we would find a way, very rough sketch here, we were finding ways of sliding it or translating it up or translating it down. And that was basically all we were looking for. And when we were looking at this yesterday, we saw the way to do this was by changing the y-intercept, the c value. This value causes the graph to translate. If it is positive, it causes it to go upwards. And if this value is going to be negative, it causes the value to go downwards. So for example, if this was plus 5, it would slide the quadratic graph up by 5. If it was minus 5, it would cause the graph to slide downwards by 5. In this lesson, we are not going to be focusing on this, which is, technically still our y-intercept. It's where it crosses the y-axis here. We're not focusing on our y-intercept in this one. Instead, we're trying to stretch and flip it. And to do this, we're going to take a different approach from last time. I know last time we looked at Desmos, and if you still remember that video, you may already know which one of these two, either A or B, we're actually going to be messing with here to cause this graph to go from this to this, and then flipping over this. Each one of these things is going to be done by a single factor. So we're going to take a different approach to this today. If you like Desmos, you can go check out the other video because I do, in that video, tell you which one of them does this if you're a bigger fan of Desmos. But in this one, we're going to just be using the table. So the same table we had last time, I'm going to try and keep all these same things here. We have f of x, which is still just x squared, which is wonderful. And then we've got g of x is going to be my light blue, and the dark blue is going to be this orange, h of x. We've got these three, and again, we're looking at this in terms of a table. Grab my little fancy line tool here. Beep, 1 and beep, 2. So the very first one, we're going to have just different x values here, and I can see that we've got basically, looks like we've got some nice hard answers at a couple of different things here. Let's see. None of these are quite lining up the way that I like. Oh, here's a good one. I like this one. Basically, what I'm doing here, in case you're not realizing it, I'm trying to see which of these x values do all three of the points have a nice lattice point. And this one's not bad either. It's just one of them is going to be 1.5. So I'm going to grab -2, -4. We'll do +2, +4, and then we'll do 0. So I'm going to grab those points specifically. -4. -2. Once again, your table is going to look a little bit different than mine, the one you have in the book, because I think that one includes like -3 and everything like that. I'm kind of cherry picking these values so that we can look at these together. So let's just do f of x first. F of x is the black line here, and I'm just going to be focusing on what my y values are. So just on my black line. So at -4, my value is equal to 16. At -2, my value is equal to 4. At 0, I'm equal to 0. At +2, I have +4. And then at 4, I have 16. Classic quadratic table here. It goes down, hits the vertex, and then comes back up again. Down, hits the vertex, comes back up again. That's how we know it's a parabola. 16, 4, 0, 4, and 16. Now we're going to do our g of x line. Same type of thing. At -4, my value is -8. -8. At -2, my value for g of x is, each one of these values is 4. So if that's the case, then this is going to be -2. So at -2, wait a second, is that still right? Yes, we are still right there. All three of them come to 0 at this center point. So in other words, we have this point here, we have this point here, and then we got this point here. Our next point's going to be right here, which is going to be 2 and 2, it looks like, +2. And then once again, because it's a parabola, -8, -2, 0, 2, I can see the pattern. This will be 8. This comes out to be 8. Oh, these are still negative. Still on the bottom side of my x-axis. Now that I've got those, I'm going to kind of use this to put together my g of x equation. Cool? And I think this is actually one of your first problems here. So, hey, if you couldn't figure it out by yourself, here's an answer. G of x is equal to, so here's my pattern from before. I know that this is still quadratic. I know that this is still going to be pulling this x squared. So I know I'm starting from here, but I have to find a way to change it. We're finding a way to stretch and flip the graph. So what in the world am I going to do to this thing to cause it to stretch and flip? How do I get this from this value to this value, or this value to this value? What do I need to change about it? So first things first, I'm going to consider a. Is there a coefficient I can add that is always going to cause it, this value, my f of x value, to turn into this value? So in other words, if this was -4, g of, I'll put in -4, is equal to -4 squared. Cool? We know that -4 squared does give me 16 for right now, but I want my answer to give me -8. So I've got -4 squared. Is there a value I can multiply this by, a coefficient I could multiply this by, to give me -8? So when I multiply this, this gives me 16 times what is going to be equal to, I need -8 now. So I know that if I multiply this by 1/2, I'm going to get +8, which means if I multiply this by -1/2, I will get -8. So that is an idea that might work. So once again, kind of illustrating what I'm looking at here, this is my starting equation, x squared. I need to see what do I need to do to x squared to get down here. So if my answer is 16, if I multiply this by -1/2, that will give me 8, -8. So let's try that and see if it works for all of them. So x squared multiplied by -1/2. Once again, right here, 4 multiplied by -1/2 would give me, well, 4 times 1/2 is 2 times -1/2. That one works. This one works. 0 times -1/2 is still 0, so this one works. 4 times -1/2 works. Also, again, this is just the same thing happening. And then 16 multiplied by -1/2. Ooh, getting messy. 16 multiplied by -1/2 also gives me -8. So that works. This is just trial and error for me right now, so I was able to see, okay, for me to get from 16 to -8, I have to multiply by this. For me to get from 4 to 2, I have to multiply by this. For me to get from 0 to this still works. 4 to -2, and 16 to -8. -1/2 works for all of this. So that's one way of writing the equation out, or I could write it like a coefficient, kind of like how it's written up here. So I could also write it as g of x is equal to -1/2 times x squared. And that would be my new equation. So that would be the equation for g of x. Cool? So we didn't even have to actually test out the b value here. We found the answer with a. So a is going to be the main coefficient that's going to cause this to either stretch or flip, depending on what we do with it. Cool? So now we have g of x's equation. We're going to go through and find h of x's. Same pattern as beforehand. H of x is still basically taking what we did with, oops. I need to get rid of all that red stuff. Hold on. Rewind time. There we go. Perfect. And we know the answer to this is g of x is equal to -1/2 x squared. Woo! How are we doing? Okay, we're doing good on time. All right. So now that's our equation here. Our h equation, h of x is equal to, once again, we do know it's still going to have something to do with x squared, but our coefficient is going to be different this time. We got to find out what is the coefficient that we're multiplying by x squared to get these values. Just like last time, I'm going to fill in each one of my h of x values. So once again, looking up here at -4, on my graph up here, at -4, I'm at way up here at positive 32. Wow. Positive 32. Remember looking, what is the relationship between these two? At -2, I'm at positive 8. At 0, I'm still at 0. All three of these are lined up at 0. At positive 2, I'm at positive 8. And once again, at positive 4, I'm all the way up here at 32 again. Once again, nice classic parabola. The numbers go down, and then the numbers come back up again. So, something I want you to keep in mind, h of x is not related to g of x at all. This whole thing in the middle is not related. So in fact, I'm just going to remove it for right now because we're only focusing on these two. In other words, how do I change 16 into 32? 4 to 8, 0 to 0, 4 to 8, and 16 to 32. We know we're looking for a coefficient to go right here. So what number times 16 is going to give me 32? 4 times that number should give me 8. 0 times that number will give me 0. 4 times that number gives me 8, and so on and so forth. And you may have already figured this out. Not too hard. For example, 4 times what gives me 8? Well, it's 2. 16 times 2 also gives me 32. 0 times 2 gives me 0. 4 times 2 gives me 8 again. And 16 times 2 gives me 32 again. So this time, our coefficient is not 1/2, but instead 2. And there's our two equations. There's our g of x, which caused it to flip the graph upside down because of this negative. The negative flips the graph upside down, and the 1/2 causes it to get a lot wider, kind of stretches it out long ways this way. Meanwhile, this value down here, the 2, caused the graph to kind of come inwards a little bit. It went from here and kind of stretched it inwards a little bit, kind of like someone squeezing the graph in. Which means if I was to instead, let's say I had another equation, so GH, let's do like J of x. Let's say I went farther than 2 and made this 4x squared. It's going to squeeze it in even more, and the 4x is going to be really skinny on the inside here. It's going to continue to squeeze the graph in. We're going to stretch it inwards, okay? But that's a fictional graph. It doesn't exist in this problem. Cool? So that is the basis of what you guys are looking at here. Fill in your graph and think about, from your original equation of f of x, how do I get from this number to this number? Cool? Rewind all this stuff. Oops. Complete your graph, or your table in this case, and think about, am I going to this one or am I going to this one? And go from there. Cool? If you guys have any questions for me, please let me know in the chat. And yeah, have a great spring break, you guys. I will be having my Zoom meeting tomorrow morning. And yeah, adios.